Okay, ladies and gentlemen, as we continue talking about integration by parts and having to move pieces around to ensure that they are integrable, in this case, let's take a look here. Cosine x e to the x, well, u equals cosine x. dv equals e to the x. dx, derivate this, we come up with negative sine x. Here we integrate, we come up with e to the x. Now, the problem is if I go down and back, I still have negative sine x times e to the x. So I don't want to stop here. I want to go again. Well, derivate this again. I'm going to get negative cosine x, and here I'm going to get e to the x again. Okay, so we go down. That's a minus. But what about back? Well, unfortunately, I can't go back either. So if I kept going, I would, let's see here, cosine x, and so that's going to be a sine x, and that's going to be an e to the x, and that's going to be a cosine, negative cosine x, and that's going to be an e to the x, and it's going to go on forever and ever and ever. So what we need to do is we need to figure out a place to stop, and that place to stop is right here. Reason being, if I put all these together, cosine x e to the x, plus, because I have negative, sine x e to the x, minus the integration, because I have a negative here, of cosine x e to the x. Well, what is that all supposed to equal? Well, the whole point of this process is that it equals this guy right up here. So it equals the integration of cosine x e to the x dx. Now, if you'll notice, we can combine some like terms. This cosine x e to the x is exactly the same as this cosine x e to the x. So if this is a subtraction, the way to get rid of it is to add. And when I do that, I now have cosine x e to the x plus sine x e to the x equals 2 integral cosine x e to the x dx. Now it's a simple matter of, if I want to know what this equals, divide everything by 2. And that becomes your answer. Now, over the past couple videos, we've been talking about integration by parts, and we've done it straight, we've done it repeated, we have done it with redistribution, we have now moved terms around from within it. The question becomes, where do you stop? Where do you keep going? Where do you stop? What do you choose? And the answer is it's going to be a little bit different each time. It's going to be a little bit different each time because you're going to be faced with different situations. And in this case, neither one of these is going to go away. So the best you can do is match your original, move it over, and solve it algebraically. In other cases, where, for example, we had e to the x squared, you reorganize your material. That works out well. In some cases, a straight-up integration by parts works nicely. In all of these things, you need to know how to do integration by parts to be able to apply it.